In this video, we're going to continue discussing how to calculate probability for normally distributed variables. And this time I'm going to show you how to do it on your TI-84 calculator. We start the problem the same way in that we need to identify what we're given in the problem and what we're being asked to find, so mean, standard deviation, boundary values. We're going to skip calculating z-scores and go straight to a normal distribution curve, I know how to talk, because the calculator doesn't need to convert to z-scores first. The calculator can do calculations for any normal distribution, not just the standard normal. To access the command for a cumulative normal distribution, we're going to press second and vars. Second and vars is going to open something called the distribution menu. We can see it right here above the vars key. And the distribution menu contains a bunch of commands relating to common distributions in statistics. And you'll see the first two say normal. We've got another normal, a t, a chi-squared, and f. There's some more further down, binom, and Poisson that come from discrete data instead of continuous. Geometric is another discrete. So lots of distributions in here. Normal CDF is going to be our most common command. It's important to note you're never going to use normal PDF. For continuous variables, we're not interested in the probability of a single value. We're interested in probability for a range of values, and that's cumulative, normal CDF. That function is going to ask you for 4 pieces of information. So it's going to ask you lower bound, upper bound, mean, and standard deviation. I put this in here and just realized that that applies to a second video. It's not going to ask you this now. Because you will indicate that with the 2 boundary values. This is in a later video. We'll come back to that. Once you've entered the 2 boundary values, lower and upper, and then the mean and standard deviation, you're going to go down to paste and hit enter. And it won't let me go down there because I haven't entered an upper and lower bound. Paste is going to put the command on the home screen. You're going to have to press enter again to run it. What I'd like to do is do some examples so we can see what this looks like in practice. So for these examples, we know that the golf scores for Rancho San Juan High School's 2024-25 season were normally distributed with a mean of 68 and a standard deviation of 3. So I'm going to list what I'm told. I know that X represents an RSJ golf score. I'm told that that variable is normally distributed with a mean of 68 and a standard deviation of 3. The question then says, find the probability that a golfer scored below 65. So Px is less than 65. And you'll notice we've already done steps 1 and 2. Step 3 is draw the picture. I don't have to do any conversion. So I'm going to go ahead and paste this picture, but I'm going to change some things down here. Those labels from before were for the standard normal where we were counting by z. This curve is not a curve for z, it's a curve for x. So that middle line is my mean of 68. And I'm counting by standard deviations, which is 3. So going forward, I'm adding 3, 71, 74, 77. Going backwards, I'm subtracting 3, 65, 62, 59. So when I'm working with my calculator, I don't have to convert to a z-score. I do need to make sure that I set up my picture so that I'm counting by standard deviations and that my mean is in the center. We're going to go ahead and mark our boundary. So 65 is sitting right at that one standard deviation mark below the mean. And it's a less than problem, so this is to the left. I can see that my upper bound is 65. My lower bound is not shown on the picture. I happen to know that this curve is continuous and that it goes forever and ever, and it never quite touches the x-axis. The x-axis is an asymptote, but it is going to go forever in both directions. Technically, my lower bound is negative infinity. But my calculator doesn't have an infinity button. I need to approximate that with a really, really big negative number. And to do that, we're going to approximate that with 1e99, specifically negative 1e99. That's your calculator's way of writing scientific notation. That's 1 times 10 to the 99th power, which is a negative 1 with 99 zeros after it. So really, really, really negative. Next thing I'm going to do is, now that my picture's labeled, I'm going to grab my normal CDF function. And I'm going to write out what I'm substituting into it before I do it on my calculator. This is what constitutes showing work when you're using a calculator function. And I'm going to pull up the calculator function so we can take a look at it. Second vars, option 2. You'll notice it says mu and sigma. I'm writing mean and standard deviation. That lets me know that you know what those numbers represent. And now I'm just going to plug those values in. So I know my lower is negative 1e99, which is the default for my calculator. The upper is 65. That forms the boundary for the shaded area in the picture. And then I know my variable is normally distributed with a mean of 68 and a standard deviation of 3. And when I run that, that's going to give me my probability for x being less than 65. I'm going to clear this out so you can see where the 1 comes, or the e comes from. If I want to type negative 1e99, I'm going to press the negative 1. And then to pull up e, I'm going to hit second comma. I want that engineering notation, not the letter e. We don't want the green e that represents the alphabet. I want the engineering e that represents scientific notation. Upper 65, mean is 68, standard deviation's 3. I'm going to press enter to select paste, and I can see that command on my calculator screen, and I'm going to press enter to run it. And so we get 0.158, and then 655 is going to round up to 7. So there is a 15.87% chance that a randomly selected RSJ golfer scored below 65 in the 2024-25 season. All right, we're going to try the next two. So the next one says find the probability that a golfer scored above 70. So above is a greater than. X is greater than 70. I want my standard distribution, or not my standard distribution, my normal distribution curve. And I'm going to label it just like I did before. 68 is my mean. I'm counting by 3s because my standard deviation is 3. And then I'm going to mark my boundary value. So 70 is just a little bit less than 71, and greater than is to the right. So this boundary's here. Now I encounter the opposite problem that I had in the previous question. This upper bound goes to positive infinity. So for that, I'm going to use positive 1e99. Once my picture is drawn, I'm just setting up my normal CDF command. So normal CDF. My lower bound in this case is 70. My upper is 1e99. My mean is 68, and my standard deviation is 3. So let's go ahead and enter that in the calculator and see what it gives us. And this time we get 0.2525 rounded. So there's a 25.25% chance that a randomly selected RSJ golfer scored above 70 during the 24-25 season. You'll notice in both of those cases that we shaded a tail that was less than half the curve, because here's my halfway point. That's less than half the curve. For the second picture, here's my halfway point. That's less than half the curve. And the probabilities I got were both less than half. So that makes sense. In this case, I'm one standard deviation out, so I know I should have about 16% in that tail, because I've got 68 in the middle, which leaves 32 for the sides, and half of 32 is 16, so it makes sense that that rounds to 16. Here I'm just a little bit inside of that one standard deviation, and so there's a little bit extra beyond the 16, and that's why I'm getting that 25%. So checking that what we got from our calculator makes sense in terms of the picture and empirical rule is a great way to check our work. For the last example, I'm just going to go ahead and do this one really quick on our calculator. It says find the probability that a golfer scored between 66 and 70. And that one's nice because they've given us a lower and an upper bound. So when I go to normal CDF, my lower is 66, my upper is 70. And you'll notice my mean and standard deviation are there from the last function call. Your calculator should retain that last mean and standard deviation until you change it in one of the distribution menus or you reset your calculator memory. So for this one, we get P x is between 66 and 70 is equal to 0.4950. And looking at a distribution, I'm going to be lazy and copy paste here. Looking at this distribution, I see that 66 is just a little bit inside of one standard deviation. 70 is just a little bit inside of one standard deviation. And I know from edge to edge, one standard deviation to one, that right there is 68%. So my answer should be less than 68%. And this is just under 50. It's about 50% of the data. That makes sense for the section of graph that I've shaded. All right, if you have any questions on how to use your TI-84 to calculate a probability for a normal distribution, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.